All right, so we want to go over solving a compound inequality graphically. All right, so we've been doing solving them algebraically. Now, if you were solving this graphically, you right here are given a graph of a line. But just for fun, could we come up with the equation? What is f of x's equation? F of x equals, what could we do to find this equation? Well, we could think about the slope and the y-intercept. So the first thing I notice is the y-intercept is 0, 2. And so therefore, if we think about y equals mx plus b, the b would equal to 2. And then I see that the line is going down from left to right. So that means my slope is going to be negative. My slope is rise over run. So I can think about, well, how much was my rise and how much was my run? So if I'm going down, my rise is -2 and my run is a +6 because I went from 0 to 6. And you could also do the slope formula if you want. Now our slope m is part of this equation here is equal to rise over run. And so I have -2 over 6, which does reduce down to -1/3. And you could see actually I could have gone down 1 over 3, down 1 over 3. It's the same, right, as going down 2 over 6. So these are just equivalent fractions. So if I put that together, I have f of x equals -1/3 x plus 2 is my equation. So if I were doing this backwards, you know, without the line on Desmos, I could type this in and I would see this line here get graphed, right? And we want to solve when f of x, meaning this line, is less than or equal to 1. And so in order to do this, we're going to actually graph the line y equals 1. So on Desmos, you could even start with y equals, you can use f of x or y equals the equation of the line, and then y equals 1, you type that into your Desmos, and you're going to see that anytime you have y equals a number, you're going to get a, what do we call this? A horizontal line, okay? And so that's what we have graphed here. Now, once we graph that horizontal line, and they're saying here, comment, it really helps to use colored pens when solving this kind of problem so you can see the different colors. In fact, I just made that a different color. Now it stands out better with the red. So we know that they're equal to each other. So if I was going to solve graphically, where is f of x equal to 1? That would be my point of intersection if I was going to solve that, right? So where it's equal to 1, the point of intersection, x is equal to 3. So this point is 3, 1. And to solve this, we would say x equals 3. But we want to know, where is f of x less than or equal to 1? So it's equal to 1 at the point of intersection, and it's less when it's below. So all of this area right here, we're going to be using x to describe that. Since we're solving, and anytime you're solving means you're going to find x, what x values here would make the function less than 1? And so that solution is a whole interval, right? It's not just 3, but it's anything when x starts out being 3 and going this way. And so that interval would be from 3 to infinity. Okay, so note, or next note, f of x is less than or equal to 1 is true for when x is greater than or equal to 3. And that's what I have here as an interval. Okay, so the solution set as an interval is, we put the bracket around 3 because we're using less than or equal to, so we can include 3, and then we're going to positive infinity. And so our solution set, this is what we call interval notation, and our solution set in set builder notation is going to be x such that x is greater than or equal to 3. So you just put the inequality inside the set notation. And we call it set builder as opposed to set notation though, because remember it's an infinite set, so we can't include every single number, or we're not going to be able to list every single number in the set. All right, let's look at example 12. So here we still have the same line f of x. And so this is basically the same thing as the inequality -1 is less than or equal to -1/3 x plus 2, which is less than 3. So here what we're going to do is we're actually going to do two horizontal lines. So our first horizontal line will be at y equals -1, and our second one is y equals 3. And so what you can actually see here, and this is already graphed for us, here's the vertical line, horizontal line, sorry, horizontal goes this way, okay? Horizontal line, y equals 3, and here's the horizontal line, y equals -1, so we graph both of those. So if you were doing this in Desmos, you would take this part here and you would graph that as f of x, and then you could graph y equals -1, y equals 3, and we're looking to see when is it in between, right? So here is where f of x is in between, and we're going to look for what x values are those corresponding to. And so you can see that here on the number line, when x is -3 all the way up to when x is 9, f of x is in between those two horizontal lines. And that's where we're looking for it to be, is in between from before. Okay, so the solution expressed in interval notation would be from -3 to 9. Think about why we're putting parentheses around the -3 and a bracket around 9. And that has everything to do with the inequality. Okay, it's because here we're saying f of x is less than 3 as opposed to less than or equal to. That's why we're using the parenthesis here. All right, and then this would be the set builder notation. This really means the exact same thing, it's just in a different form. Okay, for the above example, refer to the graph and solve f of x is greater than 3, f of x is less than -1. So that's example 13. So if we were to think about like the opposite, right? If I want to know when, let's do a different color, when it's greater than 3 and less than -1, then I'm on the other side of the line, right? When f of x is greater than 3, we're up here. When f of x is less than -1, where's -1? Right here. We're down here. And so we want to think about what x values, would give us those y values. So our interval, if we were solving basically the opposite question, here would be from, the interval would be from -∞, because here it is, -∞, to 3, sorry, -3. And I'm putting parentheses around the -3, -∞ to -3, union, because we can't be in both places at the same time, so that's why we're using the word or, from x equals 9 to +∞. And again, because we have less than -1, we're below the line, which is y equals -1. And so we have from 9 to infinity. And we don't put brackets, we're putting parentheses around the numbers because there's no or equal to in either situation. Okay, let's look at another one. Here we have, given the graph of a function, use the graph alone to solve the inequality or the compound inequality. So for the first one, f of x is greater than -1. So I'm going to start by, I have my line f of x. We don't have an equation for it, but just like I was saying before, we could come up with the equation of the line. And I think that's a really good practice anyway, because it's just something we want to know how to do. So think about for a minute what you think the equation of f of x is, just for fun. It's not being asked here, but I'm just kind of taking it a little bit further. So think about if you know what the equation is.
1.
Yeah, what is 1?
1 over 1.
1 over 1 is the slope?
Or negative, let's see, negative 1 over, yeah, negative 1.
Yeah, and also you might notice the y-intercept is also 1. So the slope is negative 1. So we would have f of x is equal to negative x plus 1. So slope of negative 1 because the line is going down, y-intercept of 1 because and then the rise, negative 1, 1, 1, 1, negative 1, 1. Okay. So now that would be this, basically the reason why I bring that up is this would be the same exact problem if I had negative x plus 1 is greater than negative 1. And you know you could use algebra to solve, right? But we're solving graphically. So in order to solve graphically, I will start by drawing the line y equals negative 1. If I draw that line here, this is their point of intersection. So x equals 2, if we were saying, where is f of x equal to negative 1, x would be 2, right? But we want to solve where is f of x greater than negative 1. So I have to look on what side of the line to see greater than negative 1.
The left.
Yeah, so everything up here is greater than negative 1. All the y values are greater than negative 1. And so we want to think about, well, how can I represent this, the values of x? What is the interval, since I'm solving, what is the interval that would give me those results? So it would be from negative infinity, because remember we're thinking about the x values, all the way up to 2. So from negative infinity to 2, these are the x values that give me f of x is greater than negative 1. Okay, now we're just putting this together with, so we have here for f of x, let's do it in a different color. Oops. So if I want my two barriers, I have y equals negative 1, which I already have graphed here. This is y equals negative 1. And then I have y equals 3. I'm going to graph that up top. And I want to know when is it in between those two values. And so right here is where we're in between. And you can see the f of x is in between those two values. So we want to think about what interval, what x values would correspond. So here's my x values there. So think about what interval the solution would be, the x values. It would start, let's see. So x is, any thoughts about that? What interval? Thinking about the points of intersection. So here's x is negative 2, all the way to x is 2. And I'm probably supposed to do open circles, right? Or for included here, when it's equal to 3, I could include this point. So from negative 2 to 2, right? Okay. Now, for the parabola, I do want to mention a few things. This is going to be a review for the final, just thinking about these 3 questions. Could I come up with the vertex form of this equation? What would be the vertex form? Let's assume that a is equal to 1. And I'm not sure that it is on this parabola, but let's just think about what the vertex form would have to be. Remember, the vertex here is negative 4, negative 4. So if we assume that a is equal to 1, we would have f of x, or actually this is g of x, isn't it? For the parabola. G of x equals A is 1, so I just leave that A. X plus 4, because it's the opposite sign, squared minus 4. Just a little bit of review on that one. So that would, and then, you know, if you were to FOIL that and subtract 4, you could put it into standard form, which is standard form is ax squared plus bx plus c. And then if you factored that, you could have a plus m times, oops, not a, x plus m, x plus n could be the factored form. So we have vertex form, standard form of a parabola, and factored form. And the factored form gives us the x-intercepts. The standard form could give us, 0c, could give us the y-intercept. And then the vertex form can give us the vertex. So those are just 3 different forms we learned about a parabola. But essentially here, if we're saying f of, or g of x is this parabola shape, when is it greater than -2? So I start by drawing my line y equals -2. And then I want to see where is it greater than that. So if I highlight from here, these are my points of intersection. So one question could be, when is g of x equal to -2? And that would be these points of intersection here. So when it's equal, we could say x is equal to -5 and x is equal to -3. Those are my x values. And then if I want to say where is it greater, I'm going to have some intervals, right? So it starts from -infinity to -5, or from -3 to infinity. So it can be helpful to find the points of intersection first, but these are 2 different questions, right? This is the solution for this one. Now, if we're saying, where is g of x less than or equal to 4, that's a whole different interval. So I start with y is equal to 4 right here. And then I might highlight where it's less than, g of x is less than or equal to 4, and that's this whole area. So again, I'm starting with my points of intersection. I have -6 is x, right? And I have -2. And so since we're less than or equal to, we have -6 to -2, that's our interval. And I just did them all in interval notation. Okay, so think about if you have any questions to that, and then we'll go over some questions now.